This is Math 139, Section 4.3. We've been working with our rational expressions, and in this section we're going to learn how to solve equations that contain rational expressions. Here's a quick list of kind of steps, but they'll probably make a little more sense to you after we've done a couple of examples. First of all, you've gotten used to this. You want to factor before you start to do anything else. Factor all the denominators. Use the factored forms to do two things. List the values that are excluded from the domain, and then also find an LCD for all of the fractions. Now that we have an equation, we can do something to the equation as long as we do it to both sides. So we're going to multiply both sides of our equation by the LCD. This is really our big new step. And again, it's only possible because we do have an equation, so we can do the same thing on both sides. When you simplify, this should get rid of all the fractions, and you should end up with an equation that's recognizable, something we can solve that perhaps is linear, maybe quadratic. Let's try a few of these. In number 1, there's nothing to factor, so I'm going to go right ahead and identify my LCD as 3 from the first fraction times x minus 5 from the second. And of course, there's no denominator here. It's really a 1 if you want to put it in. So I'm going to take my equation and I'm going to multiply by that LCD. 3 times x minus 5. If you want to put it over 1 just to keep track of where the numerator and denominator are, it's not a bad idea. I'll do the same thing on the other side. I'm going to multiply by 3 times x minus 5, the LCD. And I can always put that over 1. So again, notice I have not violated any rules of algebra. I've multiplied both sides of the equation by the same thing. All right, over on the left, these are factors, so I could divide out those 3's. That's just a 1. And if I distribute the 2, I now have 2x minus 10. Over on the right-hand side, I'm going to have to use this LCD twice. When I multiply by the first term, and maybe I'll go ahead and write this out just to make sure that it makes sense to everybody. When I multiply it by the first term, I can see that eventually those x minus 5's will divide out. And when I multiply it by the second term, 2 times 3 gives me 6 times x minus 5. I don't really need that 1 on the bottom. So let's get rid of those x minus 5's there. And I have 7 times 3 is 21, plus distributing 6x minus 30. Now again, you may have been able to go from this step to this one all at once, and if you're comfortable with that, that's fine. I just want to make sure I don't lose anybody by skipping steps. Okay, we've got 2x minus 10. On the right-hand side, I'm going to combine my like terms. 21 minus 30 would be negative 9. And I'm going to subtract the 6x. Which gives me negative 4x minus 10 equals negative 9. I'll add the 10, so negative 4x equals positive 1, and the divide by the negative 4. So x is negative 1/4. One thing I did forget to write out at the beginning, and I should have, but it's a good time to talk about it now, is when I looked at this original denominator, we identified the LCD, but I did forget to jot down the domain. I was supposed to list those values. Here it's clear that x cannot equal 5, because that would put a 0 on the bottom. The reason I do that is to double check my final answer and make sure that my answer is not one of those excluded values. In this case, it's not. So we'll go ahead and keep x equals negative 1/4 as our final answer. All right, let's try a couple more. In number 2, I can factor the right-hand side, so let's do that first. Factoring out an m makes that m times m minus 5. All right, 2 things. Let me not forget the domain this time. That can't be 0, so m can't equal 5. This m can't be 0. And this just says m can't be 5 again, which we already knew. As far as the LCD, I'm going to have the m minus 5. And then the extra m needs to get included, but I already had the m minus 5, so I don't need to add it again. All right, now that we know the LCD, let's use that and multiply both sides of our equation by that common denominator. So left-hand side times the LCD equals right-hand side times the LCD. And again, I like to put that LCD over 1 just to kind of keep track of what's in the top and what's in the bottom. All right, on the left side, because of the plus inside the parentheses, I do need to distribute. So 1 times this is just going to give me m times m minus 5 back again. Plus, and let me just show you how I often do this a little bit mentally. When I distribute here, I can see that those m minus 5s are going to divide out. So I'm really just going to get 4 times m. If you can do that in your head, it just saves you some writing. If not, you certainly can write out that step like I did up here. On the right-hand side, there's only one term inside the parentheses, so I can just go ahead and say m divided by m is 1, m minus 5 divided by m minus 5 is 1. All I've got left is 2 divided by 1, or 2. Well, that got a lot simpler in a hurry, didn't it? I'm going to distribute the m here. M squared minus 5m plus 4m equals 2, or m squared minus 1m. And because this is quadratic with an m squared, I know I usually need to get quadratics equal to 0. So I'm going to subtract that 2 right now to create the 0 on the right-hand side. I'd like to factor this, and since I'm lucky I do have an a of 1, I know I can start with m times m. I then need a sum of negative 1, product of negative 2. Let's see, 1 and 2, with the 2 being negative, that'll multiply to negative 2, add to negative 1, so we're okay. M plus 1, m minus 2. And that's going to give me solutions of m equals negative 1 and m equals positive 2. I always want to double check, make sure those were not the excluded values, and in this case they weren't, so I have 2 good solutions to that equation. All right, we have a few more examples to do. Let's stop here and we will finish in the next video.